Okay, so here we go with example 4 for trig sub. This one's going to be kind of a doozy. But here we have the integral of 2x to the 5th times the square root of 2x squared plus 1. I know this is going to be some kind of tangent, but I have to figure out exactly what it's going to be. That 2x squared, I probably want to be tangent squared theta to make it tan squared theta plus 1. So let's figure out what x has to be. So then I'll solve for x here. X squared is half tangent squared, and then x is 1 over root 2 tangent theta. So that's the sub we're going to use. So then dx is going to be 1 over root 2 secant squared. And then I can transform it. I have the integral of 2 x to the 5th becomes 1 over square root of 2 to the 5th tangent to the 5th. And then just like we said, 2x squared plus 1 becomes tangent squared plus 1 becomes secant squared. Under the square root becomes secant. And then I gotta multiply by dx, and I'm running a little bit out of room here, so forgive me. 1 over root 2 secant squared theta d theta. I didn't write my d theta there. So, wow. Okay, let's just clean up everything. We'll clean up the constants, because I think that's really making this a lot worse. This becomes 2. I have 1 over root 2 to the 5th and 1 over root 2. That makes 1 over root 2 to the 6th, which is 1 over 2 to the 1/2 to the 6th, which is 1 over 2 to the 3rd, which is 1/8. So I've got 2 times 1/8, so that becomes a quarter. Integral tangent to the 5th theta times secant cubed theta. And so now back to the trig integral section, we're going to have to figure out what kind of substitution we want to do. I'm going to wager a bet that it's probably going to want to be secant. Now, why do I say that? If I pull out if I want to let u equal secant, let me delete this over here so it's less distracting. And I'll also delete this extra. If I want to let u equal secant theta, I'm going to have to take out one of the secants and one of the tangents to make up for the du. So that'll leave me with 4 tangents and 2 secants. And then the tangents, because it's an even power, I can make them back into secants with the Pythagorean identity. So that's sort of my short-term reasoning there. Once I do that, du will be secant theta, tangent theta, d theta. So then I have 1/4 integral tangent to the 4th secant squared. All I'm doing is I'm pulling out a secant and a tangent. Secant theta, tangent theta, d theta. Still preparing for the substitution. I want to change everything except this into secants. So tangent to the 4th, I want to write as tangent squared squared. So secant squared minus 1 is tangent squared. And when I square that, I get tangent to the 4th. Secant squared theta. Secant theta, tangent theta. And now I'm ready to plug everything in. This gives me 1/4 integral u squared minus 1 squared times u squared du. Oh boy. Let's see what we can do with this. We're going to have to FOIL everything out. So, quarter integral u to the 4th minus 2u squared plus 1 times u squared. Then I get u to the 6th minus 2u to the 4th plus u squared. And now I've got, oops, No more integral sign, I'm going to just integrate. u7 over 7 minus 2u to the 5th over 5 plus u cubed over 3 plus c. I'll just go ahead and distribute that 1/4. U to the 7th over 28 minus 2 and 4 cancel with a 2 on the bottom. U to the 5th over 10, and then u cubed over 3 times 1/4, u cubed over 12, plus c, of course. Now I just got to backtrack. What's my u? My u is secant theta. Secant to the 7th of theta over 28 minus secant to the 5th of theta over 10 plus secant cubed theta over 12 plus c. And now it's time for the worst part. I gotta switch my secants. What is my substitution again? X is 1 over root 2 tangent theta. Let me write that down. X is 1 over root 2 tangent theta. So I want to solve for tangent theta because I want to make a fraction. So that means x times the square root of 2 is tangent theta. And just a reminder, tangent theta is opposite over adjacent. Now I want to solve for this last side. I'm going to do it a little carefully. X times root 2 squared, I'll call this side c, plus 1 squared is c squared. That's 2x squared. 2x squared plus 1 is c squared, and so square root both sides. And there you go. So there's my c. It is the square root of 2x squared plus 1. Now what's secant? It's 1 over cosine, so that's hypotenuse over adjacent. So secant theta is just root 1 plus 2x squared. Now I can just sub that back in. I have 1 plus 2x squared to the 7 over 2 over 28 minus 1 plus 2x squared to the 5 over 2 over 10 plus 1 plus 2x squared cubed over 12 plus c. And that's the final answer.